Hello. Today we are going to analyze the air pollution and its impact on health and weather. The problem that we are focusing on is health issue due to air pollution, weather changes triggered due to air pollution indirectly breaking ecosystem. Analysis that were taken based on the literature review, part of air pollution, which is a part of SDG 3, as it is also related to health, and SDG 13, which also related to weather. Major cities with pollutants in India and weather trends. Solution: understanding the growth and its effect using PostgreSQL and Sparks. The actual visuals output and their effects would help government to take countermeasures. The goal to track the dataset to understand the problem and urgency to implement it. The major goal is to reduce this respiratory disease and deaths due to air pollution. The dataset that we are going to use is air pollution dataset, weather dataset, and health dataset, which has 5 years of air pollution dataset, 5 years of dataset of weather, 1 year of respiratory issue dataset, deaths due to respiratory issue dataset. The dataset resources are OpenAQ, Metastat, Python library API, and Open Word Bank. For health dataset. The major tools that we are going to use is Spark, PostgreSQL, AWS, S3 bucket. Sorry. So the structure goes in this way. Using API and S3 bucket, will extract the datasets to Spark, and then Spark again helps to extract the data set from AWS S3 bucket and then insert it into PostgreSQL. And using this data that has been extracted from PostgreSQL, we are going to do EDA part. So moving towards code. So here we are going to insert the libraries that are used in this code. And then this code is used to import Spark session and a Spark session builder, and then S3 configuration of S3 bucket. So this is app name, then configuration path of SQL, and then these are the Amazon credentials that we have. So moving ahead, this is the part to my S3 bucket path for data sets. This function loads the data where I have a try and exception handler which contains schema of my data set, which extracts the data from the path of S3 bucket and then stores it into a variable. So here we sanitizes and replaces dot by underscore. Moving ahead. So we'll validate if the values that were being seen are properly shown. So then we'll convert the data that are being received from S3 bucket to data frame using two pandas and clean the data using NP numpy function to clean null values to none values. After validating this values, we'll just load the data. So this function, this exception handler will load the data of weather using a API call to Metastat for Python library. Same with health dataset, it extracts the data from S3 based on the schema that is mentioned, and then loads it to the data frame. So once the data are being loaded, so the function call will return with this 4 values like data frame of air pollution, weather data, health data, data frame of air pollution of Spark, and health data Spark. Moving ahead, it's a definition of bulk inserting the data, data frame to a SQL database. So in this function, we are going to save the data that are being extracted. So it's a function call. Here we are calling the function of function load and then saving data frame of air pollution to air pollution variable. Same thing with weather data. health data, and then if nothing works, then we'll throw the exception. Moving ahead, there's a for loop here which extracts the data of this values. If there's an issue, then it throws an error with the data set that is being mentioned. So then we'll create an connection here where we'll mention the database name, username, password, host name, and port number. With that, here we have variable with the queries that we have that's required to create a table with the condition if the table doesn't exist. I mean, if it doesn't exist, it ignores. If it doesn't exist, it creates. If it exists, it ignores. So if the table exists, it says that table created already. So with that, moving ahead, so we are writing the we are creating the table, and then we are moving towards insertion of the table using the loop. It calls every time to insert table into the table data itself. Like every time this loop repeats, it inserts data to it with the table new table name. So with that, if there is an issue with saving the data, this exception will be thrown. Once the data is inserted, we are moving ahead with performing EDA. EDA will be once we enter into EDA, we have a connection to RSQL with these three different dataset schema. Then we'll just load the data to a data frame using Spark Read Spark Read database using the credential of the database that we have. We'll do the same for all three databases and then load it to a database after converting it to uh, a data frame. So once this is done, we'll move towards visualization part of our data. First, we'll visualize a bar graph using the station name and then number of, the value that corresponds to it. This is a number of pollutants. For each pollutant, we'll show a histogram showing the frequency or the values of those pollutants. And then we are also tracking in this diagram, we are going to track how how the pollutants are being increased or decreased on each year basis. This diagram is to analyze the trends for 5 years, like 5 years period of time, to analyze it to see the weather change that happened. So with that, this visualization coding part that shows the deaths that have been happened due to the cause of respiratory issue and other issues. Then this calculates the average of PM 2.5. Here we have just access to PM 2.5, but we can also analyze with other pollutants. So we also have an average death of people who are being affected by respiratory issue. Moving ahead, this is the main function that calls the data where data is loaded with load data use US3 true. I mean, this is an argument that will be sent to load data, and then the load data will be called and return the parameters into it. So if we have any data, it moves to save the data and then perform EDA and stop sparks. Moving ahead with the output. This is the output of S3 bucket, I mean air pollution that we got from S3 bucket. So this is the output of weather data from API. This is the output of health data from S3 bucket. So this first visualization, as we spoke earlier, so is the top 20 cities with pollution rates on them. So these are the pollutants, each pollutant with their values, frequencies on it. So we have visualized all the pollutants in the data set. So moving ahead, we also have like yearly average pollutants here. So for 5 years, so when we visualize that, So this is what we got. Like in 2015, we had a much of PM10, and then year of 2020, it is reduced now. In the same way, we have also analyzed for other pollutants. To move ahead, for weather data sets, we have 5 years of weather data set, and we have analyzed the trend for weather data set. Even though we see small changes in weather data set, the weather data set drastically changes when it comes to longer period. So this is a statistical value count for weather, where we have a count of time and mean of the temperature, and then standard deviation of the temperature, minimum of the temperature, maximum of the temperature. Moving ahead, we also have a statistical analysis of health data here, with same average values of all the statistical count. And then this part is the respiratory infection and chronic respiration disease that are being caused. Moving ahead, this is the visualization as we discussed in the code. This part shows the number of deaths due to respiratory infection and tuberculosis and chronic respiratory diseases. When we see the actual deaths by all these respiratory issues, it's around moreover like 20 million, because we are looking for 5 years. We have a more number of deaths, but still it's a serious concern that has to be taken in consideration. Moving ahead to conclude and conclusion the future opportunities. So here, as we see, the number of deaths for respiratory issue has been increasing day by day, and causing one issue to lead to another issue. So this is a major issue for human being, and to see for good health of people. So government has to move ahead with good uh, planning and policies. So the future plans for this issues, I mean this prototype is, we are planning to I'm planning to stream the real data of weather, air pollution, and health diseases, and then try to analyze the effects of implementation of policies on the people. And it would also be helpful to analyze the seasonal analysis with the pollution, like when the pollution goes high, when the pollution goes less, and then take respective action against it to reduce these pollutions. With the real-time data analysis, the plan is to distribute each pollutant into individual data set, as we did for bar graph histogram that we had, which makes us to analyze the toxicity and toxic action impact of the pollutant, and how we can counteract those pollutants. As mentioned in the report, once government implements the water sprinklers, and I mean, as an example, government is implementing a water sprinkler, are provided subsidies for biodegradable fertilizers. So those agriculture, we can analyze how these actions are being impacting with our with those implementation. Thank you.